Hello everyone, welcome back to our course, and this is part on the structural equation modeling. And in this part of the lecture, we will talk how to implement the categorical variables in the SEM. Initially, SEM was created to use only numerical variables, but as you know, in natural sciences, especially in ecology, we have many categorical or discrete data. And these are examples of discrete data, such as binary, where we have two levels. For instance, yes versus no, presence versus absence, or failure versus success. Or other form is nominal, where we have different levels, but we don't know the order. Examples are different sites where we sampled, or different plots, or different countries, for instance. And the other type are ordinal levels, where we know the order of our factor. So for instance, we have small versus medium versus large, and then we know that if we move from small to large, then we have increasing order of these levels. And the categorical variables can be implemented in two ways in the SEM, as exogenous and as endogenous. And as you remember, the assumptions about the error distributions are associated with endogenous responses. So there is a less statistical problem when we incorporate the exogenous variables. And new advances in modeling allow to directly incorporate some types of categorical variables in the SEM, but some other types are not incorporated yet, and we have to do it manually. And for this, we will recap how it's done in regression analysis, because we have to use the same procedure. But in regression analysis, this is done automatically, for instance, when we use the functions LM or GLM. Then let's first recall the linear regression. And the regression predicting y has the following standard form, where a is the intercept and b is the slope of the effect of x1 on y, and the epsilon is the residual error. And if our x variable is numeric, then the intercept is the value of y when x equals 0. And for categorical variables, the intercept a has a different interpretation. So let's consider that we have variable x2, which is categorical and means species identity. And here it has two levels, species 1 and species 2. And then we know that this categorical variable can never reach 0. That's why a here instead is the mean value of y at the reference level of x. And the reference level is one of the levels of our categorical variable. And in R, this reference level is the first level alphabetically. And then the regression coefficients B here are the effects of each other level of the factor relative to the reference level. So for our two levels here, we will have one B coefficient estimated with the A, which reflects the reference level. And the procedure behind this approach is that each level of our categorical variable, species 1 and species 2, are broken into separate variables. And each of these separate variables get value 0 or 1, meaning absent or present. So, and these two variables become linearly dependent, because if species 1 equals 1, it's present, they by definition of our data species 2 equals 0, because our y variable cannot occupy two states simultaneously. It cannot be species 1 and species 2 at the same time. And now this linear dependency between these two variables allow us to set one level as a reference. And now if we have the reference, we can interpret the effect of species 2 when the effect of species 1 is absent. And that's why we have only one B coefficient when we have two levels of the factor. So now you know how these categorical variables are implemented in the regression analysis by creating dummy variables from the levels of the categorical variables. And this is what we will do manually for some variables in the SEM. And now let's talk how we integrate the exogenous categorical variables, the predictors, in the SEM. So the first approach is that we do the same procedure as I have shown you on the previous slide. So for nominal or binary or ordinal categorical variables, we can create separate dummy variables for each factor levels and treat these variables as 0 or 1, as absent or present. And then you remember that these variables become linearly dependent. That's why if we use all of them in the structural equation model, we will have the singularity, the high correlation among them. That's why we have to avoid one dummy variable because it becomes a reference level. So the key or the rule is that for the factor with k levels, we use k minus 1 dummy variables to avoid this singularity. So for instance, if we have two levels, like we had species 1 and species 2 in the previous example, then we have to include in the structural equation model only one level, let's say level species 2. Another approach is available only for binary and for ordinal categorical variables. So for binary and for ordinal, we know the order of the levels. That's why we can set these variables to be numeric. So we set the values of present or absent to the numeric 0 or 1. And then our model will be using these variables as a numeric. And this will yield a single coefficient. The same for ordinal variables. We have to set our numeric variables to 1, 2, 3, or whatever we have there, depending on the order. So if we have small, medium, and large, that we know that we move from small to large, we have increasing levels. And this will also yield a single coefficient. One more approach is to use the local estimation procedure using the package piecewise SEM, which we will learn on day 9 of our course. And next, we will do the exercises to learn how to implement the exogenous categorical variables in the SEM. For this, we will use our project, which aims to understand the effects of biocontrol agents on crop pests, which are aphids here in our case. And we did the experiment in the greenhouse where we used 3 different treatments of biocontrol agents. And first one was the present or absent of aphid predator, which is lacewing larva in our case, which is shown here on this photo. And the second treatment was absent or present of parasitic wasp. And wasp is the parasite of aphids. It uses their body as a host for eggs and for larvae. And the third treatment was the intercropping of aphid host plants with other companion plants, and especially with repellent plants like garlic or onion, because they are bad for aphid development. And here you can see our variables that we got from our experiment. And the experiment used 150 microcosms, which you can see here. So the host plant was the cabbage, where we installed the aphids. And then we studied different treatments. We used the garlic, present or absent, as a first categoric variable, and then 3 different treatments for the aphids' natural enemies. So the first was no enemies, the second was predator present, and the third was parasite presence. And now here you can see our hypothetical model. So we assume that presence of garlic together with host plant may affect the host plant biomass and thus indirectly may affect aphid density. But also as it is the repellent bed for aphids, it can directly affect their development. And then also we assume that the aphid natural enemies would also affect the aphid density, but we also want to know how this effect differ among these categorical levels. And for this, we use the data, aphid data CSV file, which you will find in the Blackboard. When you check the structure of this data, we can see that we have 150 observations, which are our microcosms. And we see that aphid density and host plant are our numerical variables. Also, the next we have garlic effect, and this is a factor with two levels, which is absent or present. So this is binary variable which we can just simply transform into dummy variable but numeric. So I here created the numeric variable which has simply 1 or 0 in our variable. And also then we want to study the enemy categorical variable. So this is factor which has 3 different levels, and levels are no enemies, predator present, parasite presence. So this is our nominal variable because we don't know the order of this variable, so it's not ordered but nominal. For this we cannot convert it to the numeric variable just because we don't know the order of levels. That's why we create 3 dummy variables from this factor using each level separately. So we create no enemies, predator, and parasite. And now these 3 variables are linearly dependent on each other. So when we have treatment no enemies equal 1, so it's present, then the other 2 treatments are equal to 0 because we do not do any interaction between these treatments. And now, as you remember, the rule here is to include only 2 out of 3 these dummy variables. And our categorical dummy variable, which is no enemies, now become as a reference for these 2. But also garlic is numeric now, and we can use it simply as a 1 variable here. So here you can see the specification of this model in Lavaan, and again I want to fit this model using our data, and I request the summary. And here you see the path diagram showing the same what we do in Lavaan. So again you see that predator presence and parasite presence are only 2 levels included in the model, while no enemies is omitted here. And here you can see the results. First, you see, of course, the fit statistics, and you can see that it's highly significant. But also important here are our regression coefficients. So we can see that garlic presence is a numeric now, and it yields 1 single coefficient, our regression coefficients. Also, predator presence and parasite presence are now our dummy variables, and they also yield single coefficients here. And now I filled in these coefficients into our path diagram. Also, I have shown here the chi-square statistics for our model. And what we see here that garlic negatively affects plant biomass, and in this way indirectly affects plant density, but also it affects directly negatively the aphid density. Also now we have 2 our variables for the presence or absence of the enemies. So we can see that predator presence affect aphid density negatively, and this effect is stronger than parasite presence. And these effects are compared to the no enemies, to our reference level. And we can call the regression lines here in order to check how this would be interpreted if we use the regression analysis. So I simply plotted the regression lines, and you can see that predator line is much more lower than the parasite line, and also in comparison to no enemies. So it's the same kind of interpretation is done here in the SEM as we would do in the linear regression. But however, in the SEM we don't have any regression lines because we do not estimate the intercepts. In addition, our interest was whether the effect of garlic presence on aphids was only direct or also indirect, and what is the total effect. And you know already how to do the syntax for the calculation of indirect effects. So we define the coefficients for the mediator, and then we calculate direct, indirect, and total effects. And here what these results show us that the direct effect of garlic garlic on aphid is much more stronger and negative than indirect effects through the changes in host plant biomass. Also, the total effect is also very negative and strong, we can say here. And now we show these results also in addition to our past diagram. I also went further. I added the all feed statistics and also the colors of links depending on the negative or positive sign of this effect. And also I like to highlight some variables that are connected to each other. And here I highlighted them in the same colors. Also, some authors in their papers go even further and they add some photos of their treatment to make their path diagrams appealing to the reader. And now it's a time to talk about how to implement the endogenous categorical variables. So if we have binary or ordinal variables, so that we know the order of their levels, then we can use argument ordered in Lavaan, which is in our fitting function SEM. But if the categorical variable is nominal, so that we don't know the order of levels, then this is not possible in Lavaan. But we can construct the composite variable and use these factor levels as a separate indicators for this composite variable. And I will try to make some example later to show you how to do this. First, let's talk about the procedure behind the Lavaan when it treats the categorical data in the SEM. The covariance-based SEM assumes normal distribution, and normal distribution means continuous data. And the ordinal or ordered categorical variables cannot be assumed normal. So the solution that Lavaan does is named limited information approach, and it treats our endogenous categorical variable using thresholds. And in this approach, we assume that our categorical variable y has underlying hidden variable y star, which is true variable, but is continuous and normally distributed. So it means that y variable represents only some partial information about the true variable y star. And the discrete categories of our y variable, which is level 1, level 2, level 3, they cut this distribution of continuous variable in specific points. And you can see here it's shown by T1, T2. And these specific cuts in the particular levels are named thresholds. But you may notice that we have only 2 thresholds, but 3 levels of our categorical variable. It's because each threshold it's a boundary between 2 anchors about our 2 adjacent levels of the factor. And the threshold, for instance, T1 here, is a match between the probability of y to be equal 1 and the actual percent that the observed data are truly equal 1. So using this method of thresholds, Lavaan treats the effect of x on the categorical variable y as the effect through some hidden true y, which is continuous and normally distributed. But the models with the threshold structure cannot be estimated with the maximum likelihood function. So for this, we use the estimator named weighted least squares, which is shown here. And S here is the observed covariance matrix, and sigma is the model implied covariance matrix. And W it's a weight matrix, which give relative weights to the data points which are more informative about the relationship between X and Y. But we will not go into details, of course, how to calculate this weight matrix. And in Lavaan, it uses by default the diagonally weighted least squares. So it uses diagonals of this weight matrix. And now let's do the exercise and implement the categorical endogenous variable in the SEM. So for this, we will use our project on the effects of human activities on fish communities in ponds. And for this, we have sampled 120 ponds, and here we sampled the fish communities and macrophytes, the plants. And here you see the variables from this project. So we have the human impact intensity here, which is numerical variable. We have plant diversity, which is also numerical variable, also diversity of native fishes, and the categorical endogenous variable is the presence of invasive fishes, which has two levels, present or absent. And here you can see the hypothetical model. So we presume that the human impact intensity affects native fish diversity, and this effect is direct and also indirect through changes in plant diversity. And plants are not only food for native fish, but also habitat. Also, we presume that human intensity affects the presence of invasive fishes in the ponds. Another link here is the covariation or correlation between invasive fishes and native fishes. By this, we assume that there is some kind of competition between these two types of fishes. And now let's take this example in Lavaan. So for this, we have data named fish data CSV in the Blackboard. And when you check the structure of the data, you will notice that the presence of invasive fish is categorical and it has two levels, presence and absence. And you have to specify the model the way you already know. And be careful here that we have the correlation, so we have to use double tilde for the correlation. And now when we want to fit our model to the data, we have to specify which our variable is categorical. For this, we use argument ordered, and we name which our variable is categorical. So for us, it's invasive fish. And then we just use summary to extract the results. And here you see the output, and you can see the first thing is that our estimator is not maximum likelihood, but diagonally weighted least squares. And additional thing is that in addition to standard chi-square statistics, we also have the robust statistics. So when we want to show the statistics, our model fit, we have to use this robust instead of the standard. And also our standard errors were estimated using the robust estimator here. And now here are the results for the regression and correlation. So we can see here that the invasive fish, it was a categorical variable, but we got one estimate for it. So it means it's was treated as a hidden continuous variable, the way I explained you in the previous slides. And now I filled in the path coefficients in our path diagram. I also filled in R-square statistics and showed chi-square statistics. What we see here, we see that human impact intensity affects negatively native fish, and this is direct effect, but it also affects indirectly by reducing plant diversity. And it affects positively presence of invasive fish. But also we see negative correlation between native fish and invasive fish, meaning there is some kind of competition or there are some other factors affecting these two variables. And now it's a time for your task. For this, we're gonna again use our grassland project, but this is different because we use different data set. And these data are on arthropods. So you can see here, this is me sampling arthropods using net sampling. And for this, we used 235 grasslands, which differed in grazing intensity, but this intensity is a categorical variable with 3 levels. So we have low, medium, or high intensity. And then we use these arthropods communities and assembled food webs. And as you might remember, the food webs are the trophic interrelationship between species, so who eats whom. And then we measured the length of this food web, how long is it? And this food web length also is a variable with 3 categories. So the food web with 1 trophic level includes only herbivores and decomposers. And food web with 2 trophic levels includes also carnivores in addition to level 1. And 3-level food web includes also omnivores in addition to level 1 and level 2. By the way, omnivores are the species who eat on different trophic levels, so not on the same trophic level, but on a different trophic levels. And here is our hypothetical model that you need to test in this task. So notice that here you have two categorical variables. First one is exogenous. It's a grazing with 3 levels. And second one is endogenous. It's a food web length which has 3 levels. And other variables like soil organic carbon and plant biomass and plant species richness are numerical. So here are the tasks for this exercise. First, you need to take this entire model and specify it in Lavaan. And if needed, try to recode the categorical variables in a way that it would be appropriate to do this analysis. And third, feed the model using the data, which are food web data CSV, and you will find it on Blackboard. Then get the fit indices, fill in the standardized coefficients and R-square for the model, and this final task is to think about how to interpret the results. So good luck with this exercise and see you soon in the next lecture.